So here we have a number line with 0, 1 and 2 labelled. Now to get from 0 to 1, we have 10 lines, which means that each of these lines stands for 1/10. Below, we also have two big rectangles, and each rectangle is split into 10 pieces, so this will help us count in tenths. If we shade one of our pieces on our rectangle, we have 1/10, and as a decimal, we write 1/10 as 0.1. So the number before the decimal point tells us how many holes we have, and we don't have any whole rectangles, but then the digit after the decimal point tells us how many tenths we have, and we have 1/10. We can also use place value counters to show tenths. So if we count on another tenth, we now have 2/10, which is 0.2. 3/10 is 0.3, and you're probably getting the hang of this, so I'll speed the video up. 4/10 is 0.4, 5/10 is 0.5, 6/10 is 0.6, 7/10 is 0.7, 8/10 is 0.8, 9/10 is 0.9, and if we count on another tenth, we have 10/10, but that's the same as having one whole. So we have 1 or 1.0. Remember, the number before the decimal point tells us how many holes we have, and we now have one whole rectangle, and the digit after the decimal point tells us how many tenths we have, and we don't have any extra tenths. We can also show, using place value counters, that if we have 10/10, we can exchange those 10/10 for one whole. Now if we carry on counting, we have 11/10, which is the same as one whole rectangle and 1/10 of another one, so that's 1.1. Now we have 1.2. 1.3 means we have one whole and 3/10, and you're probably getting the idea again, so I'll speed this up. 1.4 is 1 and 4/10. 1.5 is 1 and 5/10. 1.6, 1.7, 1.8, and now we have 1.9 because we have one whole rectangle coloured in, and we have 9/10 of another one. So 1 whole and 9/10 is represented in decimal form as 1.9. If we count on another tenth, we now have 20/10 coloured in altogether. We have two whole rectangles coloured in, so that's 2.0, because remember, the digit before the decimal point tells us how many holes you have, and the digit after the decimal point tells us how many extra tenths you have. And here, these 10/10 again can be exchanged for one more whole. So 1.1 is equal to how many tenths? Well, 1.1 means we have one whole, and the one after the decimal point tells us that we have 1/10. Remember, one whole is the same as 10/10, so if we have 10/10 and then an extra 1/10, we have 11/10 altogether. 1.4 means we have one whole and 4/10. One whole is the same as 10/10, so 10/10 plus the 4/10 means that 1.4 is equal to 14/10. 2.7 means we have two wholes and 7/10, so altogether that's 27/10, because remember, each whole can be exchanged for 10/10, and if we have two wholes, that makes 20/10. Then, if we have another 7, that's 27/10 altogether. So, to show what we have, if we have 1.1, we have one whole and 1/10, but we can split our whole into 10/10, which means we have 11/10 altogether. 1.4 means we have one whole and 4/10, but if we split our whole into tenths as well, we have a total of 14/10. and 2.7 means we have 2 wholes and 7 tenths, but if we split each of our wholes into tenths, we have 27 tenths altogether, because each of our wholes can be split into 10 tenths. Now, 13 tenths is what as a decimal? That's 1.3, because remember, 10 of these tenths can make 1 whole, and then we'll have 3 tenths left over. 29 tenths is what as a decimal? That's 2.9, because if we have 20 tenths, we can exchange for 2 wholes, and then we have 9 tenths left over. And here we can see 13 tenths, because each fraction bar is split into tenths, so each piece is 1 tenth, and we have 13 of them, but we can exchange 10 tenths for 1 whole. And if we have 29 tenths, we can exchange 20 of these tenths for 2 wholes, and then we have 9 tenths left over. We can also show what we've done using place value counters. So 1.1 means we have 1 whole and 1 tenth, so we can have 1 whole place value counter and 1 tenth place value counter. But the question asked us to write that as a fraction over 10. So we exchange 1 whole for 10 extra tenths, meaning that we have 11 tenths altogether. 1.4 is 1 and 4 tenths, so that's 1 whole and then 4 tenths as our place value counters, but again the 1 whole can be exchanged for 10 more tenths, giving us 14 tenths altogether. 2.7 is 2 wholes and 7 tenths, so we can show 2 whole place value counters and 7 tenths, but each of our 2 wholes can be exchanged for 10 more tenths, giving us 27 tenths altogether. Then we had 13 tenths and needed to write that as a decimal. So if we show 13 tenths, we can exchange 10 of our tenths for 1 whole. That gives us 1 and 3 tenths, which we write as 1.3. And if we've got 29 tenths, we can swap 10 tenths for 1 whole, and then we can swap another 10 tenths for another whole. That means that we have 2 altogether and 9 tenths, so that's 2.9. Finally, let's work out the values of A, B and C on this number line. We have 0, 1 and 2 labelled, and to get from 0 to 1 we have 10 little lines, so each of these lines represents 1/10. A is on our 4th line, so that's 4 tenths or 0.4. Now for B, we have to be careful. This comes after 1, and remember, each line is 1/10, so this value here is 1 and 1/10, which we write as 1.1. And C is 8 lines after 1. Remember, each of these lines was 1/10, so C represents 1.8. Thank you so much for watching. I really hope that was helpful. If you're a teacher or a parent, then please subscribe or go to keystage2maths.com to download resources for this lesson and many more. That's all for now. I'll see you in the next video.